Hello. In this video, we're going to learn about simplifying fractions. This is the next step if you're learning about equivalent fractions, how fractions work. Now we're going to start to learn about how to simplify fractions. So to get started, let's take a moment to kind of go back and do some quick review on what fractions are. You probably know fractions are parts of a whole. So if I have this whole right now and I divide this up, you can see I have 1, 2, 3, 4, 5, 6, 7 different parts. So I'm going to say that I'm going to shade in two of these parts. And when you're shading in a diagram, you don't have to worry about coloring in perfectly. You want to make sure it's clear. And right now it's clear that I've shaded in these two parts. I call this a quick shade. There's a total of 7 parts, but I've shaded in 2 of them. So the fraction that I'm working on right now, the fraction that I'm showing, is 2/7. We know that when we're learning about math, it should always have a relevance, a purpose. So the question is 2/7 of what? Maybe this is a bar of chocolate, and that's 2/7 of a bar of chocolate that had, a particular candy mixed into it. Maybe it's 2/7, meaning each one is a person in a group, and 2 of those 7 people were wearing a purple shirt. Maybe, though, I'm representing Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So maybe this is a way of showing days of the week. And I know that on Wednesdays and Thursdays, I have a special activity that I do. My favorite show is on Wednesdays and Thursdays, whatever the example is. And I could say 2/7 of the days of the week, I have this special thing going on. So let's take a moment to look at the idea of 2/7 in a little bit more detail. When we talk about 2/7, let's talk about what that actually means. We know that fractions are represented with 2 main parts. We have the numerator, and that's the name of the number that goes on the top of the fraction. And then we have the denominator. The denominator is the number that's on the bottom. So we've got the numerator and the denominator. And let's talk about what this actually means. The easier one to define, believe it or not, is the denominator. The denominator is just how many parts the whole is divided into. So that's what the denominator is. The question is, how do we define numerator? And that can be a little bit tricky because oftentimes the numerator is really dependent on what the context is of the fraction, what you're talking about. For example, if I slide this up a little bit here, what if I'm talking about how I have 7 toy cars and 2 of them are blue? So my numerator is 2. So is the denominator how many parts it is? Okay, but then 2 are blue. So is my numerator going to be cars? Or is, in this example, I had a cake with 7 slices, but my dog ate 2. Oh no. So is 2 slices? Some people tend to confuse the idea of a unit, how many cars or how many slices, with the meaning of the numerator. The numerator is not the same as the unit. Even though we could say 2 cars or 2 slices, or in this case, I have lots of meetings. In 1 week, I have 2 days with no meetings. So is 2 days or is it no meetings? That's the problem, is the meaning of it changes from depending on what your context is. So I like to give students this really weird definition for a numerator, and it's how many you're talking about. And as strange as it sounds to have such a general definition, that tends to make a lot of sense for people because a more specific one, it really depends on what you're talking about. Is it how many cars are blue? Is it how many slices of cake my dog ate? Is it how many days I have with no meetings? The meaning of exchanges, so I like to keep it really broad and say it's how many you're talking about overall. So we know that fractions have to represent equal parts. So let's say I make an agreement with somebody and I say, I am going to share a cookie with you. And let's see, I'm going to give you 1/2 of it. Now we know that means that there are going to be 2 parts total, and I'm giving you one of those 2 parts in all. Okay, so here's my cookie, and I'm going to chop it in half. And this part, that's your part right there. Of course, that's not half. Of course, that's not even. So we would say that this is not a fair fraction. No way, because my fraction here is not representing an equal part. So let's try it another way. Let's say we're going to share a pizza, and I'm going to give you half of it. Again, that's 1 out of 2 slices of pizza. So here are my 2 slices, right? I mean, it's true. I do 2 slices, one here and one big one here. But yeah, that doesn't make it equal still. It's still not a division because we know that fractions must represent equal parts. So this, again, this is not a proper way of showing a fraction. What if we decide I'm going to share with you a candy bar? So let's see, here's a bar of chocolate. And again, we're going to divide this up into 2 parts. I'm going to give you one. Boom. Here we go. Again, not evenly divided. That's not going to work either. I need to figure out how I can develop equal parts. So if I am sharing my cookie, I'm going to make sure that I'm dividing it up so that it is perfectly in half, so that the 2 halves are the same size. And now that's going to work. Or if I'm splitting up a pizza again, well, you can use the exact same way of drawing it that I did before. But I should point out that dividing something in half, it doesn't have to go vertically or horizontally, although maybe this time I will divide my pizza in half. You get a half and I get a half. And yes, that's going to work out much more clearly and cleanly. If I'm dividing up my candy bar right over here, it's not the most beautiful drawing, but if I'm dividing up my candy bar, I have to make sure that I cut it right in half. So I got 2 equal sized pieces. And the same rule is in effect with other fractions, not just with 1/2, that you always have to make sure that you're using equal parts when you're working with fractions. So then the question is, what does equal mean, or what does equivalent mean? Well, let's talk about different ways in which we can think about the idea of equivalence. Let's talk about the idea of the number 5. So if I asked you what are other things that equal 5 or that represent 5, that are equivalent to 5, I could think of a whole lot of possible things that might work. I could say, I could use tally marks, 1, 2, 3, 4, 5. That's equivalent to 5. I could talk about a way of representing it using dots, like on a dice, on a die, I should say. That's a way to show 5. I could use the letter V if I'm using Roman numerals. V in Roman numerals, that means 5. I could write out the word 5 as a way of showing it. I could write it in Spanish, cinco. So there's so many different ways that I can represent that. I can also represent that using an equation. I could say 2 plus 3. I could say 4 plus 1. I could say 6 minus 1. I could say 10 divided by 2. All of these represent the idea of 5. So we could say that they are equivalent to 5. I could do the same thing, using another number. Let's say I'm talking about 50 cents. And I want to see, okay, what are different ways to represent 50 cents? So first, I could write that in dollar notation. But I could also write that as, I could use a $50 to show 50 cents. I could represent that using a quarter and another quarter. That's going to show me 50 cents. I could represent that using a dime, another dime, 30 cents, 40 cents, 50 cents. I could use that showing nickels. I'm just going to show 10 nickels here. I could show that using 50 pennies. Or I could use some combination of a whole lot of those things. I could show using a quarter, a dime, so that's 25, 35, 40, 45, 46, 47, 48, 49, 50. All of these ideas show the idea of equivalence. And the same is true with fractions. I can represent an idea in multiple ways with fractions. For example, let's say I again have let's do the cookie example again. Here's my cookie. I'm going to split it into two parts. And I'm going to say that you get one of those two parts. But I could also take that same fraction, that same amount, and I could split it up in a different way. For example, I could split it up into 4 parts. I could split up that fraction in yet another way. Let me just recreate it here. Into 6 parts. Or I could even split it up into 4 parts and then 8 parts. Each one is showing me in that same amount. You'll notice it's still half the cookie. I've just cut it up in different ways. And so I can represent those as different fractions. For example, I could come in and I could say that this first fraction, well, I've got 2 parts. The part I'm talking about, the part that I've colored in red, is one of them. So that's showing me 1/2. Here, I've got 1, 2, 3, 4 parts. That's going to be my denominator. That's the whole. And 2 parts are shaded in. That's 2/4. I could here count 1, 2, 3, 4, 5, 6. 6 parts with 3 shaded in. That's 3/6. Or here, I could count 1, 2, 3, 4, 5, 6, 7, 8. 8 parts in all with 4 parts shaded in. All of these are equivalent fractions. And we can show that with some equal signs here, meaning the same amount is shaded in. If I divide this up and I take the red part, I'm getting the same amount of this cookie no matter which way I cut it. It's still the same amount. These are equivalent fractions. And that's the idea of equivalence. It's the same amount. So let's talk about different ways in which we can find an equivalent fraction. So we've got here that fraction of 1/2 again. And I want to look at ways I can represent that. So if I've got 1/2, I want to come up with a way to show those equivalent fractions. I'm not always going to be able to draw it out the way I did right here. What are some ways in which I can show that just by using my math skills? And to do that, we're going to work on multiplication. So what I need to do is figure out what I can multiply my numerator and my denominator by, but it has to be the same number. And the trick is, honestly, I can pick whatever number I want. I can multiply them by, let's say, 2. So I'm going to multiply my numerator by 2 and my denominator by 2. And so 1 times 2, well, that equals 2. And then 2 times 2, that equals 4. The rule is, and you're going to hear me say this a lot in this video, what you do to the top, you've got to do to the bottom. And what you do to the bottom, you've got to do to the top. As a rule of thumb with fractions, that's a really important concept to remember. And so I can even draw that out. Now, if I use my same example that I had on my last page, here's my cookie. I split it in half. I now have, oh, that's not the best coloring, but that's all right. Sorry, dropped my pen. If I cut that up, I've multiplied it in half. I need to divide that into twice as many parts, which I've done right here. So let's continue though, working on this. I can take my 1/2 again. And maybe this time, instead of multiplying by 2, I don't know, let's multiply it by 3. Switch and get a fresh color too. Remember, what I do to the top, I have to do the bottom. So if I'm going to multiply my numerator by 3, my denominator, yep, got to multiply that by 3. Well, 1 times 3 is 3. 2 times 3 equals 6. So just like I had on the previous page, if I've got my cookie and I know that I'm splitting it up and I'm going to eat this part here that I'm representing with my red shading, I now have 3 times as many parts. So I split it and make 3 times as many. Okay. So before I was getting just that one piece, but now it's 1, 2, 3 pieces. Doesn't mean I'm getting 3 times as much of the cook. It just means that my whole has been done to 3 times as many. And so the section I'm getting is 3 times as many parts. I could go back. Oh, let's try it again. I can make my 1/2, my half cookie. I'm even going to draw it out at the beginning this time. Let's shade in my portion. So this time, let's divide it up so that I'm going to multiply it by 4. What I do to the bottom, let's start with the bottom this time. Doesn't matter because what I do to the bottom, I've got to do to the top. So 2 times 4, that equals 8. So I'm going to take my numerator, 1 times 4 equals 4. And so now when I go to divide this, I'm going to split it up into fourths. And boy, that actually matches what I had here at the beginning when I turned it into 2/4. And I'm going to further divide it to make eighths. It's not a perfect drawing, and I'm sorry, I cut that off here. You didn't even see what I was showing you right here. But I could split it up and I can turn it into eighths. So there are a lot of different ways that I can figure out what my equivalent fractions are, but I want to talk about how I can do it without drawing it out. Because like I said before, you're not always going to be able to draw it out. So let's use that same idea of drawing those arrows as a way of showing how I can find my equivalent fractions. So let's say I've got 4/12 this time. Well, I can pick something to multiply them by. So similar to what I was doing before, I can say, let's multiply them by, I don't know, 3. Any number. I mean, I could multiply each by 10 and make 40 120ths. But for now, let's do times 3. 4 times 3 equals 12. And 12 times 3, that equals 36. Now again, that's not the only way that I can multiply that. I can choose whichever way I want. For this next example, let's do the same fraction. Let's do 4/12 again. But for this next example, let's multiply it by something else. Let's multiply it by 5. This would be a great moment. If you want to pause this video and see if you can try and make the equivalent fraction to 4/12 by multiplying by 5, go ahead and you try it and then hit play when you're ready to resume. All right, so 4 times 5 equals 20, and 12 times 5, that equals 60. So you can see I could multiply it. I don't want you to think that I couldn't do times 4 just because it went from times 3 times 5. I could do times 2, times 3, times 4, times 5, times 8, times 17, times 49 if you had a reason to want to do it that way. But you can multiply equivalent fractions by just about anything. You can multiply numerators and denominators by just about anything or not even just about anything. You can multiply them by anything in order to generate equivalent fractions. Any number will work for multiplying them. But it gets a little bit more complicated when you're trying to go backwards. And here's what I mean by that. I did 4/12 just now, but I can also use smaller terms to represent what I had. For example, instead of multiplying by 3 or by 6 or by 10, I can divide. So I can say, instead of 4 times something, what's something that I can divide by? Now, this is where that rule that I taught you a few minutes ago becomes really important, because what I do to the top, I have to do to the bottom. So I know on the bottom, oh, I could divide 12 by 3. Yeah, but can I divide 4 by 3? No, I can't. I have to think about what's divisible by each number. So let's see, I could divide them by, oh, I could divide by 2. Let's try this one. I could divide 4 divided by 2 and 12 divided by 2. 4 divided by 2, that's 2. And 12 divided by 2, that's going to be 6. So 2/6. That's an equivalent fraction. I can represent all of these. I can put in some equal signs for all of these. That's an equivalent fraction. Or I could do it another way. I could do 4 divided by, let's see, sorry. I could do 4, let's try dividing by 4. Because I know I can divide both of these by 4. 4 divided by 4, that's 1. And 12 divided by 4, that's going to be 3. Whenever you're using division to represent a fraction in smaller terms, using smaller digits than what we had before, that's what we call simplifying. So both of these, when you're multiplying, like what you see kind of when we move to the right into larger terms, and when you divide to get smaller terms, both of these are considered finding equivalent fractions. This is all equivalent fractions. But when you're dividing in order to use smaller terms or similar terms, that's when we start talking about simplifying. So I'm just going to put this section here into a box to show you. This is the part that we would call simplifying fractions, and that's really our focus for today. So let's take a look at some other ways that I can do it. Like I said to you before, I like to think of moving to the right when I draw those arrows. I multiply and get bigger numbers, that's to the right, and I divide and get smaller numbers when I go to the left. So let's say I started off with a fraction like 9/21, and I want to simplify that fraction. I can do that. I can use division, and I can show that in a few different ways. Again, I need to think what's something that 9 is divisible by and that 21 is divisible by. I need to look for common factors of 9 and 21. For example, let's see, like 21. I know 21 is divisible by 7, but 9's not divisible by 7. I couldn't use that. But they are both divisible by 3. So I can go back, I can show, I'm going to divide them both by 3. Remember, what you do to the bottom, you have to do to the top. What you do to the top, you have to do to the bottom. So I'm going to continue to divide these up. 9 divided by 3 is 3, and 21 divided by 3 equals 7. So although you may not notice it just from looking at it, but 9/21 and 3/7, those are equivalent fractions. But I've simplified it by putting it into smaller terms. Now, let's keep on going here. Let's continue with this. Because I can also represent this in a different way. Some people like to draw the arrows. For me, as a 4th grade teacher, I think arrows make a lot of sense for kids. But maybe they don't make sense for you the same way. So another way that you could draw this, it's a little bit directly, 9/21. And you can just write that as 9 divided by 3 divided by 3 equals 3. sevenths. 9 divided by 3 equals 3. 21 divided by 3 equals 7. However, I do want to caution you right now because sometimes people want to write it like this. 9/21 divided by 3. That would not be a correct way for you to write it. 9/21 divided by 3 is going to give you a totally different fraction. You're no longer going to be working with equivalent fractions. You do not want to write it out like that. It's going to get you a little bit mixed up. So let's try a different fraction that we can work with. Let's try instead the fraction 8/12. So I'm going to give myself a little bit more room to work with this. 8/12. So I want to try to, I'm going to use division. If you want to pause this video and you want to give it a try, please be my guest. So I'm going to go back. What can I divide them both by? Well, I know that I can divide them both by, I can divide them by 2. And 8 divided by 2 equals 4. And 12 divided by 2 equals 6. Now, it is true. I've simplified that. However, it is not yet in simplest form. That means that I can continue to divide. I can continue to simplify. So I can divide this again, can take another step through here, and I can divide them, let's see, 4 and 6. 4 is divisible by 2, and 6 is divisible by 2. That could work. 6 is also divisible by 3, but 4 isn't. That's not a common factor. So yeah, I'm going to divide by 2 again. 4 divided by 2 equals 2. 6 divided by 2 equals 3. So 2/3. And I can't divide that any further. They have no common factors other than 1. And dividing it by 1 is not going to change anything. So I know that this is now in simplest form. Again, if you don't like drawing with arrows, you can just write it like this, 8/12, and then I can go straight to my division. But you have to decide, what are you dividing by? Now, I could divide by 2, and then by 2 again, and have those 2 steps, or I could recognize, what is the largest common factor that 8 and 12 share? Yeah, 2 is a common factor between 8 and 12, but so is 4. So I could do 8 divided by 4 and 12 divided by 4. 8 divided by 4 equals 2. 12 divided by 4 equals 3. And I can jump right to my simplest form just by finding a larger number that I can divide by. Let's try one more here. Let's do instead, let's try 12/30. So if I'm trying to simplify 12/30, now we're working with some larger numbers. It's going to be a little bit more challenging for me, but you know what? I'm ready for the task, and I think you are too. If you want to pause this video and you want to try to simplify 12/30, please be my guest. I know, let's see, what's 12 is divided by 4. I could divide 12 by 4. But I don't think I can divide 30 by 4 because, let's see, 4 times 6 is 24. 4 times 7 is 28. 4 times 8 is 32. Now, I can't divide 30 by 4. So I'm going to try dividing. Oh, I can divide 12, though, by 3. I could do the same with 30. So I'm getting a little stuck for space here. 30 divided by 3 and 12 divided by 3. Well, 12 divided by 3 equals 4, and 30 divided by 3 equals 10. Again, this is simplified, but it's not yet in simplest form. So I can keep on simplifying because both of these are divisible by 2. 4 divided by 2 equals 2. 10 divided by 2 equals 5. There's no other way for me to continue to divide up 4/10 or 2/5. There's nothing else I could divide them by. So we call that, again, simplest form. And if you don't want to write it that way, you can certainly write it out as 12/30 30ths. And again, I don't have to draw these two steps. I draw one big arrow because instead of dividing by 3, dividing by 2, I just draw and say I'm divide by 6. So I do 12 divided by 6. That's going to equal 2. And 30 divided by 6, that's going to equal 5. And that's absolutely going to work for me so that I get 2/5. Again, simplest form right there. I can't divide it. 6 is the greatest common factor between uh, between 12 and 30. So I can divide it. Again, it's the simplest form. Now, the last one that I want to show you is the fraction 5/16. How can I continue to divide 5/16? I know 5 is divisible by 1 and 5. It's a prime number. 16, I can't divide by 5. 16, I could divide by 2, but I can't do that with 5. I could divide 16 by 8, but again, that won't work for 5. I could divide 16 by 4, but that's not going to work for 5. They have no common factor other than 1. So we'd say that this fraction is already in simplest form. And we could say the same is true. You can misspell that. The same is true with 2/5. The same is true with 2/3. They're already in simplest form. All right. So go ahead and do some practice on your own. Try and see if you can simplify some fractions because it's going to be an important skill as we move on to other activities. Again, we were going through simplifying fractions and also learning about simplest form. I hope this was a helpful guide for you. Have a great day.